Good morning. I'm Rachel Grace Sagarino, and I will be discussing about Theorem 1, which states that two intersecting planes meet in a straight line. Now, I have here a cube with plane F and plane D, and they intersect in this line here. Now, we can call this line as line 1. And then here, we can call this point over here as point A, and this point over here as point B. Based on axiom 3, two intersecting planes cannot meet in only one point. So it must be at least 2 points and it can create a line. So these two planes intersect in one line.
We can't stop, and we won't stop. We're running, they don't run away. We don't take nothing from nobody. Yeah,
Theorem 2. A plane can be determined by 1. A line and a point not a net. 2. By 2 intersecting lines. And 3. By 2 parallel lines. Now I have here plane A. Now let point R and point S be in line 1. Then one and only one plane A can be passed through line 1 and point T because one and only one plane can pass through points R, S, and T, and that is based on axiom 2, which states that through three non-collinear points, one and only one plane can be passed. I have here plane B. Now let's put here point R as the point of intersection of line 1 and line 2, and point S on line 1 and point T on line 2. Then points R, S, and T determine the plane B as of axiom 2 that states that through three non-collinear points, one and only one plane can be passed. And in axiom 1, if 2 points of a straight line lie in the plane, then the whole line lies in the plane. By definition, line 1 and line 2 lies in a plane C. They lie in only one such plane, since points R and S on line 1 and point T on line 2 lies in only one plane.
this girl is on fire. This girl is on fire. She's walking on fire. This girl is on fire.
Theorem 3. If a line is perpendicular to each of the two lines in their point of intersection, it is perpendicular to the plane of these lines. Line 1 is perpendicular to line 2 and line 3, and line 1 is also perpendicular to plane P based on corollary number 71 that states, a line is said to be perpendicular to a plane if it is perpendicular to every line of the plane passing through its hood.
Morning, I am Joblin Elio and I'm going to explain theorem number 4. Theorem number 4 states that through a point there is one and only one plane perpendicular to a line. So I have here plane P and point A. And based on corollary number 77, if each of two lines is perpendicular to a third line at the same point, so I have here line 1, line 2, and line 3, which meet at the same point, which is point A, then the plane of these two lines, line 1 and 2, which is plane P, is perpendicular to the third line, which is line 3. Cut.
My girl just gimme, 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 gimme,
Theorem 5 states that through a point, there is one and only one line perpendicular to a plane. I have here plane P, line 1, line 2, and line 3. And based on corollary number 77, if a line is perpendicular to each of two lines at their point of intersection, so meaning if line 1 is perpendicular to each of two lines, which is line 2 and 3 at their point of intersection, which is point P, it is perpendicular to the plane of this line. So, line 1 is perpendicular to plane P of line 1 and line 2. I have here plane P, line 1, line 2, and line 3. And based on corollary number 76, if a line is perpendicular to each of two lines at their point of intersection, so line 1 is perpendicular to line 2 and line 3 at their point of intersection, which is point A. This line 1 is perpendicular to the plane of this line, which is plane P containing line 1 and line 2.
Every time I see you. I want to know.
Theorem number 6. Oblique lines from a point to a plane meeting the plane at equal distances from the foot of the perpendicular are equal. Okay. Point A and point B can create a line which is perpendicular to plane Z. And from point A, we can create two oblique lines to plane Z, which has two equal distances from the foot of the perpendicular. Based on corollary 82, which states that the perpendicular is the shortest distance from a point to a plane. So, this is the point, and this is the shortest distance from a point to a plane.
I got the eye of the tiger, dancing through the fire. 'Cause I am a champion, and you're gonna hear me roar louder than a lion. 'Cause I am a champion.
Conversely, two equal oblique lines from a point to a plane meet the plane at equal distances from the foot of the perpendicular, based on corollary 82, which states that the perpendicular is the shortest distance from a point to a plane. Hence, the distance from a point to a plane means the perpendicular distance.
귀요미 초코머핀 한 조각 시켜놓고 고소한 우유